Let's say I want to make some flood analysis. So I have some flood that's happening, just a simulation. Let me show this in QGIS as an assumption. Let's assume that in Istanbul, in the Bosphor Canal, we have some, not in the Bosphor Canal, next to the Bosphor Canal, we have two dams, this dam and this dam. Recently, there were so many dam breakages, so let's consider this dam breakage. Let's say that this dam broke down. It did not hold the capacity. It broke down, it collapsed, and what do you say? The water came here and flooded all of this area, all of this residential area. So what will happen? How will the buildings be damaged? How much the cost will be in total? So what do? You run a flood simulation, water flood simulation, and using any software simulation, for example, HECRAS, it's very popular. Some people did it, and this is their paper. Let me show you their paper. Wait, 1 second. Let me show you their paper. This paper. This paper, they used HECRAS, and they have also some pictures, some nice pictures. Let me go and show you. This picture is the place. It's this area. This area is the thing that's in the picture. This is the water depth map. So I opened it. It's bad quality, but you can see how much the water depth map. It's a water depth map. I can't say anything about it, like just the water depth map. So I also have those files. The depth map is in a CSV file. So it will be each point with a 5 meter radius has some calculation. So let's say this point, this is the x-axis and this is the y-axis, and this is the water depth at that point, plus all the 5 meter area around it. I have so many of those. It's 2.4 million points for the water depth. I also have the same for the velocity. So for each point, what is the velocity? I can import it to QGIS using layer, and then add layer, and then add delimited text file. They are called delimited text files because they are delimited with a comma. So the values are separated with a comma. So let's add this depth map. The x-axis will be x and the y-axis will of course be y, and I will add it. Those are the coordinates, and this is the projection for my CSV file. This is also very important. I added it, and as you can see, those are all the points, 2.4 million points. There are so many. I can, for example, let's go here and select and go even further, and then select this point, for example. Now you will see here the value, the water depth value at that point, and like 5 meter radius around it, or any other value. I don't know how much the radius is exactly. I also have my buildings. I want my buildings. They are in shapefile format. Those are my buildings. Those buildings, for example, they have a type. They have an attribute, a type of T1. Let's say those are residential, but let's say they are educational buildings, because here's a university. Here, let's say they are commercial buildings, because here's something. Anyway, they are of type 2 because they are commercial buildings. Maybe they have more expensive equipment that will get damaged more by the flood, so the cost will be higher. And I also have those urban farm buildings. Call it any way you want. So I should take into account this too. And what do I want exactly now? I have, for example, this building. I want to take a buffer that surrounds it, of course. This buffer is, let's say, 5 meters, and I want to take all the points that are inside this 5 meters, not inside the building, no, inside the buffer. Let's take a buffer. I select let's duplicate it first. Let's duplicate it, and then I will rename it to buffer. And now I have it. I will select it and then go here and type buffer. Edit selected features, not this one. Edit selected features. Yes, I can do it like this. Anyway, I can do it like this. No, I can't. Edit selected features, buffer. I will take a buffer of 5 meters. Here's how many points around the corners. Anyway, I want 5 meters of distance. I will hit Okay, now it took a 5-meter buffer around all buildings, as you can see. I also don't want the thing that the building itself, so I will take this one minus the building. So I will take difference. So I will take this one. I selected it first, minus buildings. So I finished. As you can see, it made a buffer that has no inside. I want now to take all the points that are inside this buffer, all the points that are inside this buffer only, and calculate their average. After calculating their average, I can say that this building has some the average water depth for this building, or the area that surrounds this building, is say 5 meters. So the damage rate of this building was let's say 10%, and then the cost, it was a residential building, so I multiply all this by the cost, not the cost exactly, the cost per meter squared. So let's do that. I can do it manually for each building, but that is cumbersome because I have so many buildings. So let's do it for all buildings at once as a batch process. How can I do that? With databases in QGIS, or in QGIS and geo software in general. You have the shapefile format. This is common format. There's also another file format for storing geodata that's called GeoPackage. GeoPackage, what's special about it is that it's a database format, so you can interact with it using SQL. Now I will show you. Let's first create this file or database. You call it, what do you want? Like, call it any name you want. I will name it was it building? Yes, building, or buildings anyway. Let's save it. So now it got saved here as building.jpg. Now I'll go here to database manager, and I can now go here and see my file and connect to it. I can double click it to connect to it, and I can here import layer file. I will import this one and the buffer. I will import both of them. So I press this one. I will import the buffer first, and import was successful. And now I will import the depth map. This will take some time, so I will pause the video. Now the import was successful. It's 2.4 million points, so it takes some time. Now those, because it's a database format, everything is a table. So now this buffer layer becomes a table. As you can see, this is a table, and I have 55 buildings, or 55 records. If you call it in the table terminology, it's 55 records. So my first record has geom. This geom column is the geometric data. So as you can see, it's multi-polygon, blah, 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 all the points inside for that building of ID 1. Okay, and it also has the type. I need this type too. And the depth one, I will not open it because the table of it is 2.4 million points. It closes QGIS, it crashes it because it's too many points. So one thing, I will save this, not crash it. So let's say analysis.qgis. Now I will go back to database manager. Now here I will show you the depth map using SQL. Where is SQL? It's a structured query language. It allows you to talk to databases, relational database management system. It allows you to talk to databases. It's a very important language. So it's simple, it's not that hard. I will open the SQL window, and here let's give you some example. Let's say I want to take the first 10 records of depth map table. So select every single column from the depth map, like this, and I will hit execute. And now you will see the first 10 records. I did not put all the, I want, this was all the records, every single record, of course, all the 2.4 million records. I want, let's say, the first 5 records. So I will say limit equals 10, and I will execute. It now gave me the first 10 records of the depth map table. And as you can see here, I have the value. The value is the very important one, and geom is also very important, and ID is important. Everything is important. Anyway, I want now to do something that is here. I have now, this is the points or the depth map table table, and this is the buildings table. Okay, that's geom. I removed all the columns that I don't need. I also don't need those columns. Like this. This is the depth map, and this is the buildings buffer layer. I want to take, for example, let's say that those two are inside this one, and those two are inside, and those, for example, two are inside this one of ID2. So this is building number 2. Don't confuse the type with the ID. The ID is unique for every single building. The type, 5 buildings can have the same type, residential, for example. So let's say that those two are inside building 1. So I want to make a join. This is very important. Let's put it here for remembering it. I want to join this one with building type 1 because it's inside that. So I put here building type 1, and I also have multiple records, so I also paste it again. So here's my let's say depth.fid, because this is for the depth map, and or let's say depth map.fid, not to this extent. And here's depth map.geom, and here's depth map.value or depth, and here's the buffer.fid or id, and here's buffer.geom, and here is buffer.type. I'm writing it like this because this will be very important. So as you can see, they are like this. I have the geometry and the depth value. They are joined on one condition, that those two are inside this buffer. Okay. After that, after the join, this is join, all this is join. Okay. After that, I want to group them. So I want to group. So every single point that inside building type 1, I want to group it. So it's like this. I want to group those. I want to group them here. How do I want to group those points? Like all the points that are in building type 1, I want to group them. What mathematical operation will I do? I will do the average mathematical operation of value, let's say, because it's 1. So I want to group every single point that is inside building 1, and I want to do the mathematical operation, the average. So it's just this. Okay, so there's the average and there's building type 1. Let's do that in SQL. Here's SQL. So let's first select everything from depth map. I already did it here. Let's also now join. What should I join? I want to join the buffer layer or table on a condition. This condition is that now here's a function. This is the function st with n. So what's within? So I want the depth map geometry. So each single point will be within the buffer geometry. Okay. So every single point to be inside the buffer. That's how will I join those two tables. Now let's just put a limit, for example, limit equals 10, and run it to show you what will happen. Now it finished it. As you can see, there's a larger table. From FID to value, this is the depth table. From here to the last is the buildings table. So now I joined two tables together. But as you can see here, for example, the ID of the building is the same, because I have so many points. So the first 10, of course, they are in the same building. So all those points that have different IDs are in the same building, in building 1. And I have those values, the depth value. Now I want to group all those depth values or take their average. So I should use group. Okay. Before doing the group by, let's make this data a little bit smaller. So let's remove the columns that I don't want, or let's select only the columns that I want. So I want to select, for example, I want to select not the geometry. I just want to select the value. So let's say I want to select the value from the depth map.value. So this one. Also, I want to select the building type, the ID of the building and the type of the building. So say buffer dot FID, the ID for the building, and I also want to select the type of the building, buffer dot FID, dot type. This is just for visualization, like the calculations will happen for, it will take all the columns, but here what I want to see in my table are only those. I can also make them look better by formatting my line like this, and like this. Now I will hit execute again, and it will also take some time, but it will be cleaner. Now, as you can see, it only showed me those that I want. They are like this, and like this. I can also do another thing. Let's say this one, I don't want to name it value. I will say as depth, water depth, and this one as building ID or number or whatever you want, and this one as building type, just to not confuse myself. Now, as you can see, here's the column got renamed to water depth, building ID, building type. Now let me do my grouping. So I want to group all those points, or let's say those. I want to group all those points and take their average, and all the points that are in building type, building number 1 or ID 1. So here let's do a group. Okay. So here group by what? By the building ID. So buffer dot FID. So I'm grouping by this one. Now I want to do some operation, some grouping operation on the water depth. So I will take their average, AVG average of the depth map value, and I will keep the limit 10, and then I will execute. Now, as you can see, it finished. Here's the average, or let's name this to average water depth. Let's run it again. Now, as you can see for the second time, is the average water depth for the area that surrounded building 1, and the average for building 2, and the average for building 3, and so on and so forth. This we just did it with those 9 lines of SQL or structured query language. Call it whatever you want. Now I have this data. I can also remove the limit because I want all the 55 buildings, but I don't want to kill the computer right now. So I want this data. I will hit Control A and then Control C to copy it, and then go down here and then paste it, and check your settings for how to paste, and then paste it. And now, as you can see, here I have all of my data in Excel. I can now take this one, multiply it by anything, and then minus something, and then I get my result, and then I go down, and then I get this one is damage rate, for example, or anything. You can do that, and you have your data. So this is how you do flood analysis with GIS.